Hey guys, here's the demo for the cross-platform mobile development experience with C++. So let's get started. In order to install the Visual C++ cross-platform mobile development experience, please go ahead and choose the Visual C++ for mobile development option and also choose the Common Tools and Software Development Kits option in the installer. This will not only install all the Microsoft goodies with the project and build templates, but also the third-party software that you need for doing Android development. This includes the Android SDK, the Android NDK, and other goodies that you need to get started. Hit Next. It's a pretty fast install, and before you know, you'll be all set to start doing cross-platform development in Visual Studio. Once the installation for the cross-platform mobile software is complete, you will start seeing the cross-platform node light up under Visual C++. With this node selected, you will see a variety of templates made available to you. The first template that I've selected here, which is the Dynamic Shared Library template, allows you to build an Android native library or an SO file, which can then be used to create an end-to-end application using technologies like Java and Xamarin. Another template that I want to talk about here is the Native Activity Application template. Android with API Level 9 introduced the capability to create an app completely in C++. This application type is popular for games and graphic-intensive application. So let's go ahead and create an application of this type. This solution has two projects. The Android Demo.Native Activity project is building a dynamic shared library which encapsulates all the native code. The other project in this solution, the Android Demo.Packaging project, is then taking that native library or the SO file and creating an end-to-end application or APK using the AndBuild system. Let's now take a further look at the Native Activity project by viewing the project properties. Using project properties, a user can set the target API level. We currently support API level 19 and 21. Set the configuration type of the application he's building. You can choose between a dynamic shared library or a static library and others. And also choose the platform toolset for building his application. We currently support both Clang and GCC toolchains. I'm going to go ahead and leave the platform toolset selected to Clang and click OK. Next, let's take a look at some of the source code to view the code editing and debugging experience. For doing so, I'm going to choose the main.cpp source file in the Native Activity project. As I'm going through and traversing to the source, view some of the features that we've added for code navigation. So here I have the Android_main function. For those of you who are new to Native Activity Android application types, Android_main function is the entry point function for any Native Activity app. As I'm editing my code here, you can see the Android-specific IntelliSense experience lighting up. In addition to this, we have other language productivity features such as go-to-definition or peak definition work as well. All in all, this is our attempt at building a great C++ language experience when developing for Android platform. Now let's try to take a look at the debugging experience we have to offer. The VS Android Debugger is definitely one of the best Android native debuggers out there. It's fast and reliable. In order to demonstrate this, I'm going to set a breakpoint in the source line inside the Android_main function. Notice that my debugger target window already is populated with the VS Android emulator entry. That's because I have the fast Microsoft Android emulator running in the background. Next, I'm going to hit F5, which is going to build my application and then deploy it onto the emulator. The build is really fast, and so is the deployment. As you can see, the breakpoint that I set in my source code gets hit. All the regular debugger features that you guys are used to, such as autos, the locals window, light up nicely. Users can also take advantage of looking at the call stack and using the command window to pass commands to GDB, such as in this case, passing the backtrace command for GDB. So here we have the Android cross-platform demo solution. The cross-platform util.lib folder here contains two projects, the Android project and the Windows project. The cross-platform util.lib.android project is building a dynamic shared library, whereas the cross-platform util.lib.windows project is building a DLL. Both these projects are using and leveraging a shared component. In this particular case, the cross-platform util.lib.cpp source file is shared between both the Android and the Windows project, and gets included when building the dynamic shared library for the Android platform, and also gets included when building the DLL for the Windows platform. Notice the demo_function in the source file. This function currently has a piece of code which is Android specific. The Android lock print message is specific to the Android platform, and hence the Windows IntelliSense experience is lighting up and letting the user know that this code is not going to build for the Windows platform. Now, when you're working in that shared component layer, remember when I mentioned that this code was also being used by the Android platform. The users can actually choose which IntelliSense experience that they want to see by looking at this drop-down menu. When I choose the Android platform menu, you'll notice the IntelliSense errors disappear. Using this experience, developers, when working in a shared layer of code, can easily differentiate between the platform-specific and platform-agnostic code that they add. Using this IntelliSense experience will save them from building their application again and again because they'll be warned about the differences between the code types at design time.